Hey there, in this video we're going to talk about the squeeze theorem. So if you have watched my previous video, the one on piecewise functions, you saw my discussion about this particular function. And I'll just review it really quickly, but I encourage you to watch the prior video on the piecewise functions and finding limits. So the limit as x goes to 0, absolute value of x over x, right? So here we have to use the definition of the absolute value of x. The absolute value of x is a piecewise function that tells us that it's x when x is greater than 0 and it's negative x when x is less than 0, greater than or equal to. Right, and this makes sense if you think about taking the absolute value of a number. Like if you take the absolute value of 7, you get 7. But if you take the absolute value of negative 3, right, this is telling you to do the opposite. When x is negative, we give the opposite. So it'll be negative 3, which is positive 3. You may be used to hearing, well, the absolute value is always positive. Yes, but so when it's a negative number, it's really because you're given the opposite, the negative of that negative number. So the absolute value of x over x then will be, using this piecewise function, we can put it together, right? So it will be x over x when x is greater than 0. Notice that now here the domain makes it so that x can't be 0. So I get rid of the equals, and then negative x over x when x is less than 0. So we end up with the fact that the absolute value of x over x is really the piecewise function 1 when x is greater than 0 and negative 1 when x is less than 0. Which in terms of the graph, that means that at 0, it's 1, not included, so open circle there, and negative 1 when it's less than 0. And so what can I say about the limit? The limit as x goes to 0 of the absolute value of x over x does not exist because the left-sided limit, if I go to 0 from the left, the limit is negative 1, and the right-sided limit, if I go to 0 from the right, the limit is 1. Those are not the same. So the limit does not exist. All right, so I just wanted you to find that limit. And now we're going to go into the squeeze theorem. And we're going to use the absolute value of x to try to make a conclusion. So our goal here, the reason that we're going to do this little part is that we want to find the limit as x goes to 0 of sine x over x. So that's going to be our goal. So illustrate an equality negative absolute value of x is less than sine x, less than the absolute value of x with the graph. Well, we can see, we know that the absolute value of when y equals the absolute value of x, starting with this side, it's a v. Right, so this is the absolute value of x. So what about y equals the absolute value of the negative absolute value of x? What does that look like? Then this is going to be the reflection, right, about the x-axis of y equals root x. So we get an upside down v. So that's positive absolute value of x, that's negative on the outside absolute value of x. And then sine x, what do you know about sine x? Sine x starts at 0 and it goes up and down, right? And it continues on the other side. So we want to illustrate an equality with a graph. So what this is saying is that sine x can be squeezed between those two graphs. So let's see what that looks like on a more to scale graph. So here's my graph for that situation. And so notice that, so the blue one, this is y equals the absolute value of x, and the red one is y equals the negative absolute value of x, and then the black curve is our y equals sine x. So sine x is definitely squeezed in between the root x and absolute value of and negative absolute value of x. Absolute value of x and negative absolute value of x. I don't know where the root came from. So that, and notice that these, right, sign, the highest it ever goes is 1. A pi over 2 is 1, and that negative pi over 2 is negative 1. So sign is always between 1 and negative 1. So this, even though it keeps going, is never going to go above the blue absolute value of x or below the red negative absolute value of x. So it's always going to be squeezed between those two. So how are we going to use this to find that limit I said we wanted to find? Our goal is to find the limit as x goes to 0 of sine x over x. Well, let's talk about what the squeeze theorem is. So what the squeeze theorem tells us is that if you have three functions, f, g, and h, and they satisfy this inequality, that f of x is less than g of x, which is less than h of x, for values of x near a, except possibly at a. So this is one of those instances, for example, of the domain, right? If value is excluded from the domain. But if the limit as x goes to a of f of x is equal to the limit as x goes to a of h of x, so the outside functions, and it exists, right, it equals some value L, then the limit as x goes to a of that middle function has to also be L. So with the picture here, what we have is that as x goes to a, right, the limit of the outside functions, the f and the h of x, is L. So as x goes to a, the h of x, the limit is L, and then for f of x, the limit is L. So because g of x is in between them, then the limit of g of x also has to be L. So that's what the squeeze theorem says. Why do we need the squeeze theorem? So in my example that I want to do to find the limit as x goes to 0 of sine x over x, right? I always say with limits, plug it in, but if you plug it in, notice that you get 0 over 0, which is an indeterminate form. And normally, what I've been saying in the last few videos is that you do some algebra. We have not learned any special rules. So if you've taken this class before or you're familiar with calculus, you may know L'Hopital's rule. We have not covered that. So if you know what that is, pretend you don't know. So how would you do a problem not knowing that special rule? And so for those of you that don't know the special rule, you're right where you need to be. So how do we do this if we can't do any algebra, right? Do some algebra, there's nothing to do. There's nothing that I can do to simplify sine x. It's not like when we had a polynomial and I can factor, or when I had a radical and I can multiply by the conjugate, or if I had a fraction over a fraction, I can get common denominators. There's nothing here that I can do. There isn't even an identity. It's not like I have sine 2x and I can use an identity. So there's no algebra to do. So then when there's no algebra to do, we have to find other methods. So the squeeze theorem is one of them. And then a special rule that we'll learn later, much later on. We'll learn that in chapter 4. We'll use it then. But so for here, we're going to use the squeeze theorem to find the limit as x goes to 0 of sine x over x. So that means that we want to be able to squeeze my sine x over x between two other functions. So I'm gonna let g of x be sine x over x. Right, my g of x being that middle function. So that means I need to find f and h so that I can squeeze them in. So find, and I'm gonna say slash construct f of x and h of x such that f of x is less than my sine x over x and less than my h of x. Right? So I'm trying to recreate the squeeze theorem here. So I need to find two functions squeeze my sine x over x in between those. Sometimes this is also called the sandwich theorem. And then I can find the limit. So the squeeze theorem says as long as you have this, your g of x is sandwiched between two functions, then the limit is going to be, they're all going to have the same limit. All right, so in our previous work up here, we were able to say, well, that this is true. Sine x is between the negative absolute value of x and absolute value of x, and we were able to show this graphically. So I'm going to steal this because this is kind of important to be able to find, to construct my functions. So this we already know. We know that this is true. So now notice that my function is sine x over x. So how can I turn this sine x into sine x over x? Divide everything by x. So when I divide everything by x, what am I going to have? The negative absolute value of x over x is less or equal to sine x over x, which is less or equal to the absolute value of x over x. So I'm finding or constructing two functions that I can squeeze my sine x over x in there. And what helped was knowing that sine x is already between those two. And now I'm going to find the limit, right? My goal is to find the limit as x goes to 0. So I'm going to take the limit of everything. So take the limit as x goes to 0 of all three functions. And so what am I going to have? I'm going to have the limit as x goes to 0 of negative absolute value of x over x is less than or equal to the limit as x goes to 0 of sine x over x less than or equal to the limit as x goes to 0 of the absolute value of x over x. Now at the beginning of this video, I had us find this limit. Now notice that as x goes to 0, I'm going to be a little sneaky here, and because I'm approaching 0 from a two-sided limit, right, but from the right function, from my h of x over here, I'm going to approach 0 from the left, from the right, because I'm on the right here. So I'm going to look at that from the right, and then, so for my f of x here, I'm to the left of this inequality, I'm going to approach my limit from the left. And so going back up to the beginning of this, we had the absolute value of x over x as x goes to 0. We had this as the graph, right? And so now if I'm looking at it as it goes to 0 from the right, we're going to 1. So let me recreate that over here. And so I'm going to make a note here. Note that the absolute value of x over x is this function, right? So as x goes to 0 from the right, our limit is 1. So I can say the limit as x goes to 0 from the right of the absolute value of x over x is 1. Are we okay with that? So what about this one now? What does the negative absolute value of x over x look like? The negative on the outside means that we flip the function, right? So this is my absolute value of x over x. So what is if I put a negative out here, what is that going to do to the graph? It reflects it, right? So it flips it. So this graph looks like that one, except flipped. So what was at -1 is now going to be at 1. And what was at 1, now it's going to be at -1. And now notice here that I'm taking the limit as x goes to 0 from the left, because I'm looking at the left inequality. So as I approach 0 from the left, what is my limit? It's 1, right? So I have the limit as x goes to 0 from the left of negative absolute value of x over x is 1. So I have the limit as x goes to 0 from the left is 1, and the limit as x goes to 0 from the right is 1. What can you say about the middle limit? So now we can say, therefore, the limit as x goes to 0 of sine x over x is 1 by the squeeze theorem. So that's the gist of the squeeze theorem. It's a way to help us find the limit when we have 0 over 0 and we can't do any algebra. So let's do another example. So use the squeeze theorem to find the limit as x goes to 0 of x squared times cosine of 1 over x. So what we want to do is find two functions that we can squeeze x squared cosine 1 over x in between. And so we have to start somewhere. And so we have to, and going back to here, find and construct that f of x and h of x such that we can put it in between. We can put a function in between, right? So we want to construct f of x and h of x such that f of x is between our function. So that's what we want, and then take the limit that we want. So the limit as x goes to 0, and then go from there. And so this is a little bit tricky because it's like, where do you even start? But we have to work with what we know. So I know trig functions, cosine and sine. I know that cosine of an angle is always going to give me values that are no more than 1 and as low as -1, right? So I know that cosine of any angle is going to be between -1 and 1. So I can use that to start. So I know -1 is less than or equal to cosine of 1 over x, right? Regardless of the angle, my values of cosine are always going to be between -1 and +1. And so now I can use this to start building and constructing my function. So I already have cosine 1 over x here. So now I have that sandwich between -1 and 1, but my full function has an x squared attached to it. So it's x squared times cosine 1 over x. Now cosine 1 over x, how do I get an x squared up front? Multiply everything by x squared. My x squared is positive. For any value of x, x squared is a positive number, so when I multiply it by an inequality, it does not affect my inequality symbols. If I multiply by a negative, right, I will be in trouble because then when you multiply an inequality by a negative, you have to flip the sign. But x squared is always positive, so I'm going to have negative x squared is less than or equal to x squared cosine 1 over x less than or equal to x squared. So I multiply all three by x squared. And now notice that that is my function. That is the function that I want to find the limit as x goes to 0. So I'm ready to apply the squeeze theorem. I have my function is squeezed between two functions. And so when I take the limit as x goes to 0 of all three, what do I get? So I'm going to have the limit as x goes to 0 of negative x squared will be less than or equal to the limit as x goes to 0 of x squared cosine 1 over x less than or equal to the limit as x goes to 0 of x squared. And what do I know about this limit? The limit as x goes to 0 of negative x squared, play it in, right? When you play in 0, you get 0. So 0 is less than or equal to, this is the limit we're looking for. We don't know this limit. And this one, plug it in. The limit as x goes to 0 of x squared. 0 squared is 0, so I have 0. So what do I have? I have 0. I have my limit as x goes to 0 of x squared cosine 1 over x. The thing I don't know is between 0 and 0. So what can you say? If this is between 0 and 0, therefore it must be 0 as well. So cosine 1 over x is equal to 0 by the squeeze theorem. So the squeeze theorem is essentially building the functions on the outside, and you can squeeze your function in the middle. And that is the trickiest part, is coming up with the function. But if you have a trig function, sines or cosines, that's a great place to start, because we know sines and cosines, the most they can be is 1, the least they can be, the smallest they can be is -1. So you can start there. Okay, email me if you have any questions.